Morning,
Yes.
we are discussing about completeness,
Compactness and completeness.
Completeness and compactness.
Yes. Yes.
We say that a metric space is compact if and only if every open cover has a finite subcover. What is an open cover? Open cover is a set of all open sets, and your X is the union of, we say that the set of all open sets G alpha, where alpha is any inductive set, G alpha is said to be open cover for X if X is union of alpha belongs to delta G alpha. This is your open cover. Generally, if you want to give example, you take in a metric space with respect to metric D, we know that open sphere and the set of all S or A is set of all D X comma A less than R. That is, we'll take it as mod X minus A is less than R, or A minus R less than X less than A plus R. So this is an open sphere. So every open sphere is an open set. So we can consider with respect to metric space, these are all the open sets. Now, we want to prove a metric space is compact. What do you mean by completeness? A metric space is every Cauchy sequence is convergent. Every Cauchy sequence is convergent. Now, we prove that completeness if and only if compactness. Completeness if and only if compactness. Or we say that a metric space, this is theorem 9.4.1. A metric space is compact and only if it is complete and totally bounded. Complete and totally bounded. First, suppose X is a compact metric space. Okay, X is compact with metric D. Now, first we prove that it is complete and totally bounded. Now, we say that every compact metric space, X is compact implies X is sequentially compact. X is compact implies X is sequentially compact. What do you mean by sequentially compact metric space? You have a Cauchy sequence, will have convergent subsequent. Generally, a sequentially compact metric space, a metric space is said to be sequentially compact if every sequence has a convergent subsequence. If every sequence has a convergent subsequent, if you take a Cauchy sequence, it also will have a convergent subsequence. So what do you mean by this? Cauchy sequence is convergent. So every Cauchy sequence will be convergent. That means you have X is complete. Next point, if you want to prove that it is totally bounded, when you say that a metric space is totally bounded, a metric space is totally bounded, if it has an epsilon net. What is an epsilon net? If X is the union of S epsilon A1 union S epsilon A2, so on S epsilon AN. Or we say that A1, A2, etc. AN, a finite set A1, A2, etc. AN is an epsilon net. If X is equal to S epsilon A1 union, S epsilon union, A2 union, etc. union, S epsilon AN. So now I prove that X is totally bounded means it will have an epsilon net. Definitely it will have an epsilon net. Why? Because X is compact means every open cover has a finite subcover. అంటే ఏంటండి ఎక్స్ ఆల్ఫా బిలాంగ్స్ టు డెల్టా ఇఫ్ జీ ఆల్ఫా ఇస్ ద ఓపెన్ కవర్ ఫర్ ఎక్స్ దెన్ యూ హ్యావ్ జీ ఆల్ఫా ఐ ఈజ్ ఆల్సో ఏ subcover. That means since X is compact, every open cover will have a finite subcover. That is, your X is nothing but G alpha 1 union, G alpha 2 union, etc. G alpha n. So in place of this, we take the open spheres S or S or S epsilon S, whatever it may be. Therefore, you have every or X has a finite set which will form an epsilon net for X. Hence, X is totally bounded. X is totally bounded. Now I will prove the converse part. Just listen carefully. This is lengthy but easy only. Conversely, suppose X is complete and totally bounded. Complete and totally bounded. Students, when I took offline classes, I took 50% of the syllabus up to 8 units. I have given a very important questions, expected questions. If you study 50%, definitely you will be able to get full marks, or you can pass and you will get more than 60%. But because I have to complete the syllabus, I am taking the online classes. See here in this online class, whatever I am teaching, from here also you can learn all these 8 units perfectly. If you learn also, you will get. But you decide yourself which 50% you have to learn. Okay?
Okay, ma'am.
But if you want to pass and get to good marks means definitely you have to learn 9 units pakka నేర్చుకున్నారు అనుకోండి. First 9 units if you learn means 100% I assure you that you will get full marks. If you want, you check the previous year question papers also. Okay? But I complete the syllabus. I will take all the units. You decide yourself which has to be learned. So X is complete and totally bounded. Now I prove that X is compact. What is to be proved? Required to prove X is compact. So what I will prove is, to prove it is enough that X is sequentially compact. Here you cannot take open cover because we don't know SRX, we don't know how to, the nature of X. X is a general set. That is the reason I will prove that X is sequentially compact. What do you mean by X is sequentially compact? Means every sequence has a convergent subsequence. Every sequence has a convergent subsequence. So already X is complete, and since X is complete, we prove that every sequence has a Cauchy subsequence. Sequence has a Cauchy subsequence. Students, at any place you get doubt means you can raise your hand, okay? Or you can ask the doubt. So if you want, assuming that X is complete and totally bounded, I prove that X is compact. To prove X is compact, we know that X is sequentially compact. That is, every sequence has a convergent subsequence. Every sequence has a convergent subsequence. Or ఇప్పుడు ఏం చెప్పాలంటే X is sequentially compact అంటే every sequence has a convergent subsequence and prove చేయాలి. Or that whatever the sequence that you will get, no, that is the Cauchy sequence అని చెప్తాను. So that I'll prove, so that I'll get that X is sequentially compact. సో మనం ఏం చేద్దామంటే టేక్ S1 అమ్మా. S1 అంటే ఎట్లా తీసుకుంటారు తెలుసా? మీరు మ్యాట్రిసెస్ తీసుకుంటారు చూసారమ్మా, X11, X12, X13, సో ఆన్, X1n అండ్ సో ఆన్. ఒక సీక్వెన్స్ తీసుకోండి. Be a sequence in X. You take this S, okay? So here, ఇలా తీసుకోవడం వల్ల అడ్వాంటేజ్ నేను మీకు చెప్తాను. S1 is first row, first column, first row, second column, like that you take X11, X12, X13 and so on. Why I'm taking, no? Because you have X is totally bounded. I have to make use of X is totally bounded. X is totally bounded means you have X has some epsilon net, say I is equal to 1 to n. Yes, epsilon ni half తీసుకోండి, AI for A1, A2, etc. AN belongs to X. You have, it has some epsilon net. Epsilon net అంటే half net. Okay, that means that is there exists I such that S 1 by 2 AI contains X1 comma n for all n. That means there exists a subsequence S2 of S1 such that all the terms in S2 are in one sphere of radius 1 by 2. That means take S2 is equal to, ante you have this is your S1, in this you have S2. Okay, so both are within the radius of R2. Center is AI for some I. So S2, how you write? You write like this: X21, X22, etc., X2n, so on. This is another sequence. And you have D of X2n, comma X2m is less than 1 for all n comma m. Why? Because these are all the terms which are in the radius 1 by 2, which are all inside the radius 1 by 2. This radius is half up to here. Radius is half. ఎట్లా వస్తుంది మీకు? So here S1, this is S2. All the terms of S1 and S2 are within the radius 1 by 2 units. So therefore you have D of X2n comma 2m is less than 1. So you repeat the same argument. We take S3 is equal to X31 x32, so on, x3n, and so on, in such a way that d of x3n, comma x3m is less than 1 by 2. So like this, you go on continuing. So you get all the terms, allows the terms of sequences like that, x11, x12, x13, so on, x1n, and so on, x21, x22, x23, x2n, and so on, xm1, xm2, so on, xmn. అది ఇది n పెట్టుకోండి పోనీ n1, n2, nn, and so on. So like that you have constructed. Now consider all these diagonal state. This one ante entandi, take the series on the, at the every time you have d of x km, comma kn, comma d of x kn is less than some 1 by k minus 1. అంటే ఏంటమ్మా, ఒక్కొక్కటి అన్నమాట, ఒకటి less than 1 by 2, 1 by 2 square, like that you will get 1 by k minus 1 అనుకోండి. అంటే ఎట్లా వస్తుంది, 3n ఉంటే 1 by 2 ఉంది కదా, ఎవ్రీథింగ్ ఈస్ less than 1 by 2, 1 by 2, 1 by 2, like that. Now for all mn, now consider the sequence xnn. Now consider the sequence xnn. Now this is a subsequence of xnn, which is a subsequence of s1. Okay, and also you have d of xnn, comma xmn is less than 1 by m minus 1, which tends to 0 as m tends to infinity. So what you will get, you have the sequence xnn is a Cauchy sequence. That means you have that means a convergent sequence has Cauchy subsequence. So what do you mean? X is sequentially compact, hence it is a x is sequentially compact, hence x is compact. So this is how we prove a metric space is compact if and only if it is complete and totally bounded. So ultimately what we are doing, center will be the same, radius will be the same. So we are going to convert sequences like this. This will be S1. This will be S2. Ante enti total radius aithe half untundi. All these are converging. Finally, they may tend to the center. Students, am I clear? Are you following? Here you have x11, x12, so on, x1n, and so on. This is convergent. x21, x22, so on, x2n is convergent. What do you mean by convergent? You have d of x1n, comma x1m is less than some 1 by 2. And they are all within the radius 1 by 2. Now you have xnn, xn1, xn2, so on, xnn, and so on. These are all convergent sequences. You have d of x2n, x2m is less than 1 by 2, and so on. Like that, you have to take, means the diagonal sequence is also convergent, which is the subsequence of S1. So it has a Cauchy sequence, which has a convergent subsequence, hence it is sequentially compact. When X is sequentially compact, you have X is compact. Therefore, a metric space X is compact if and only if it is complete and totally bounded. Actually, Ascoli's theorem states that actually when I taught half line, I have not given this CXR and CXC. That is set of all continuous functions on real numbers and complex numbers. They are complete metric spaces. That means in any sequence in CXR is a convergent sequence. Or CXC is also a convergent sequence. Now I am going to prove CXR and CXC are complete metric spaces for any compact metric space X. See here. Now let X be a compact metric space. Let capital X be a compact metric space. F comma G belongs to CXR. And they are continuous functions. How you define metric D of F comma G? It is, you define it as the supremum of mod F of X minus G of X. For every X belongs to X. Then we know that D is a metric on X. Now we prove that CXR and CXC are complete metric spaces. Complete metric spaces means every Cauchy sequence has a convergent subsequence. So we prove that CXR is a complete metric space. That means don't get panic about the CXR. CXR is the set of all continuous functions. Okay, and so how you define a metric on this? D of F comma G is equal to supremum of mod F of X minus G of X. So for this you take, let Fn be a Cauchy sequence. I prove that this Cauchy sequence has a convergent subsequence. Let Fn be a Cauchy sequence in CXR. Then what do you mean by mod Fnx minus Fmx is less than or equal to this one, D of F of n minus F of m, which tends to 0 as m comma n tends to infinity. I told you, no, what is the supremum? Supremum, see, you have metric is supremum. So you have F of X, supremum is less than the upper bound. So you have mod F of Fnx minus F of mx is less than D and mod Fnx minus Fmx is less than the supremum anartham. Supremum of Fn comma Fm. So element is less than the supremum. Element is the less than the supremum. So that is the reason we take mod Fnx minus Fmx is less than or equal to D of Fn comma Fm, which tends to 0 because it is a Cauchy sequence. Okay. Now, what do you mean? You know that the set of all real numbers R is complete. Since R is complete, there exists real number. That means since R is complete means every sequence is convergent. Every sequence is convergent. Therefore, there exists F of X. There exists F of X such that Fnx converges to F of X. Fnx converges to f of x. So that means you have, for each x belongs to x, we have a real number. There exists f of x belongs to R such that Fnx converges to f of x. Okay, therefore you have Fn converges to f of x. But now what you have to prove? F of x is continuous. I told you C of xr means it contains a set of all continuous functions. We prove that f of x is continuous. We know now, when do you say that a function f is continuous? Whenever mod x minus a less than delta, if f of x minus f of a modulus is less than epsilon, then we say that function f is continuous. We say that function f is continuous. So what you have to prove? You have d of fn comma fm is nothing but supremum of mod fnx minus fmx, which also represented by norm, and supremum is also represented by norm, mod norm of fn minus fn comma fm and kuda anachu, fn comma fm. Now you consider, because fn converges to f of x, you have mod fnx minus f of x is less than epsilon by 4 for all x, and n greater than or equal to n naught. Like that you have to take d of fn comma fm, because fn is fn converges to f. Fn converges to f implies mod fnx minus f of x is less than epsilon by 4. And you have your fn is continuous, and you have to prove f of x is continuous. Fn is already continuous. You have for some this n naught, for this n naught, you have fn naught is continuous at n naught. Means you have mod fn naught x minus mod fn naught x naught is less than epsilon by 4 whenever mod x minus x naught is less than some delta, or it belongs to, you have for x belongs to u, where u is a neighborhood, where u is a open set. Okay, now consider mod f of x minus f of x naught. Consider mod f of x minus f of x naught. మనం ఏం చేద్దామంటే we'll add and subtract the things. Mod f of x minus f naught x naught plus fn naught x naught minus fn naught x plus fn naught x plus అయితే ఇలా ఉంచేసేయండి, ఇది మైనస్ fn f of x naught. You add fn naught x naught and fn naught x naught. They add and subtract. Now this is less than or equal to mod f of x, sorry, mod f of x minus f of n naught x naught plus mod f of n naught x naught plus minus f n naught x plus mod f n naught x minus f of x naught. Now each is less than epsilon by 3 తీసుకోవచ్చమ్మా, 4 అవసరం లే మనకి. epsilon by 3, epsilon by 3 plus epsilon by 3 plus epsilon by 3, which is equal to epsilon. Therefore you have mod f of x minus f of x naught. We have mod f of x minus f of x naught is less than epsilon for every x belongs to u, where u is the open neighborhood. Okay, so you have F is continuous. F is continuous and enti, you have F belongs to CXR. Therefore, you have CXR is complete. Every consequence has a convergent subsequence. It is complete. This you learn for 5 marks. And the next one, Ascoli theorem is there. See, Ascoli theorem based on these concepts. For the next week, you read and come Ascoli's theorem. But it is very big theorem. It will take more than 1 hour to write in the exam. So other theorems are there, which you focus on that. In Ascoli theorem, no need to learn. Okay? Hello. Ascoli's theorem, if you read and come, you have any doubts means I will tell you. But Ascoli's theorem is a very big proof. It is having very big proof. This you don't for exam because it is taking maximum time to write. Even if you learn by putting efforts for 3 to 4 days, even then you may not be able to write. So that is the reason my sincere advice is don't go for Ascoli's theorem. In this unit, you learn 2 theorems for one is 10 marks theorem. A metric space is compact if and only if it is complete and totally bounded. And for short answers, CX are complete. And morning I told no. A subspace Y of a complete metric space is complete if and only if it is closed in Y. Okay. అంతవరకు నేర్చుకోండి ఈ 9th chapter లో. You have any doubts means you can ask me now. Hello.
Excuse me. Hello, ma'am.
Tell me.
Ascoli's theorem important as ma'am.
అంత ఇంపార్టెంట్ కాదమ్మా. దాని మీద ఏమంటారు ప్రూఫ్ ఏంటంటే మరి 7 to 8 pages వస్తుంది. Instead of learning that, you learn the theorem. X is complete if and only if it is totally bounded. Okay.
Okay, ma'am. Okay.
అది నేర్చుకోండి. I don't think to put so many efforts on Ascoli's theorem because from the first 8 units you have many theorems. Okay. But you study and come for the next week. You get any doubts means I will tell. Okay.
Okay, ma'am.
Now another 20 minutes is there. No, I will revise some concepts. Okay. Just those who are absent. So just let us give me some inputs on topological spaces. Just to go through this. Let X be a non-empty set. A function d from x to r, x to x cross x to r is said to be metric if d of xy is greater than 0. D of xy is the same as d of yx. D of xz is less than or equal to d of xy plus d of yz. This is the metric. First examples, just every day, online class also every day, I'll give you some inputs. Okay, basic definitions I'll teach you. Okay, ma?
Okay, ma'am.
Let x is r ankondi. Then how you define d of x comma y? It is mod x minus y. How you prove that this is a metric on r? We know that modulus of x minus y always greater than or equal to 0. And d of xy is mod x minus y, which is y minus x. See, you know that mod x minus y is the same as mod y minus x. So you have d of xy is the same as d of yx. Now d of xy is 0 if and only if x is y, and d of xz is mod x minus z, which is x minus y plus y minus z. You add and subtract. So you have d of xz is less than or equal to d of xy plus d of yz. So you have xd is a metric space. Like this you have to see. This is metric on this one. Discrete metric space ante we define d of xy is 0 if x equal to y equal to 1, it is x not equal to y. This is called discrete metric space. Now open set student. Daily you have to, I'm telling no, at least weekly you sit 2 to 3 hours on topology. First to try to digest the definitions. If you know definitions, then only you can prove. Let XD be the metric space. Then A is said to be open set. If for each X belongs to A, there exists some open ball SRX such that X belongs to SRX contained in A. So every open ball is an open set. Okay. How you prove? You check. You every open sphere is an open ball. Even this is useful for real analysis also. Let us consider SRX0. SRX0 is set of all d of x comma x0 less than r. If x belongs to SRX0, you have d of x comma x0 is less than r. Illa teeskondi. Put r1 is equal to r minus d of x x0. Consider SRX. SR1x. SR1x ante ela untundandi. Y, the set of all y belongs to x such that d of yx is less than r1. So you have SR1x is less contained in SRX0. We prove that SR1x is contained in SRX0. అంటే ఏం లే, ఒక స్పియర్ లో ఓపెన్ స్పియర్లు ఉంటాయి అట్లా. అందుకనే ఎవ్రీ ఓపెన్ సెట్ ఈస్ SRX0 is open set. If anybody wants to write means tell me, I will wait. It is there in the text, I think material, your material. Just to go through it. If you learn real analysis and topology perfectly, then you will be able to learn other subjects also, because function analysis is there, Banach algebra is there, all that you can learn easily. So if XD is a metric space, then phi and X are open sets. Union of any number of open sets is open. Intersection of finite number of open sets is open. Closed ball means open ante ela untundi, d of x comma x0 is strictly less than r. Closed ante d of x comma x naught less than or equal to r. What is the diameter of a set? Let xd be a metric space and a subset of x. Diameter is defined as supremum of d of xy. అంటే diameter అంటే ఎట్లా ఉంటుంది? అన్ని డిస్టెన్స్ల కంటే మాక్సిమం ఉంటుంది. You learn all this bounded set. What do you mean by bounded? If diameter is finite, then we say that it is bounded. Union of two bounded sets is bounded. ఇంత చిన్న చిన్నవన్నీ అవసరం లేదు. What is the closure of a set? A bar. Morning we were discussing. A bar is A union D of A. D of A is the derived set. Means set of all limit points. See, convergence in metric spaces and complete metric spaces. So let xd be a metric space, xn is a sequence. Then xn converges to x. If for every epsilon greater than 0, there exists a positive integer n naught such that d of xn comma x is less than epsilon whenever n greater than or equal to n naught. Or if you say limit n tends to infinity xn is x, we say that the sequence is convergent. Cauchy sequence means whenever d of xm comma xn is less than epsilon for all m comma n greater than n naught, then we say that it is a Cauchy sequence. And morning I proved for you that every convergent sequence is Cauchy. Every Cauchy sequence is bounded. xd be a metric space, then every convergent sequence is bounded and the limit of convergent sequence is always unique. If xn converges to x, yn converges to
పొద్దున చేయగలవా? ఏయ్ అన్విత జంప్ అన్నావా చంపేస్తా, కూర్చోవాలి. మంచి మీద కూర్చోబెట్టుకో, జంప్ అయితే నీకు తాటకేస్తా. వస్తుందా? అసలు నాకు మెంటలు పుట్టింది ఇప్పుడు దాకా, ఎంతసేపు ఏమి అర్థమైంది రాసుకున్నా. నేను ఇది నొక్కా ఇంత లైవ్ అంటేనేమో మనం బొమ్మ కనిపించడానికి ఏమో మెంటలు వచ్చినాయి బాబు. ఇంక ఇట్టవి ఏం వింటాము, అటు పెట్టి ఏం ప్రయోజనం.
ప్లీజ్ అన్మ్యూట్ చేయమ్మా, మ్యూట్ చేయమ్మా, మ్యూట్ చేయి.
Hello, class is not ended. Just I am proving the notes so that you are going through it. Hello? Hello?
Yes, ma'am.
Yeah. So these are the points. Just I am showing the notes so that you will read it. Okay?
Okay, ma'am.
So these are all the important concepts. Given xn converges to x, yn converges to y, d of xn comma yn converges to d of x comma y. These are all we are going to use these results to prove other theorems. Okay? Okay, now I will be leaving the class. Class is over. Okay?
Okay, ma'am.
Next class, once again, we will do 10th, unit 10. We'll go on separation.
Okay, ma'am. So thank you, ma'am.
Bye.